So, welcome back for today's session. Today I'll still be continuing with what we started in our last session. We are doing matrices, and today we'll still be doing matrices. But today I want to cover two major applications of matrices. That's Markov analysis and relative analysis. So we start with Markov analysis. Markov analysis. And what's Markov analysis? Now, Markov analysis is just the process or the probability of the movement from one state to another. So we are saying that Markov analysis is the study of movement from one state to another. You are moving from one state to another. So, for example, we can say that it has a general format of 2020. You multiply by the transition matrix, you go to another state, that's 2011. Or we can say that a CPA section 4 student times the transition matrix, which is KCE exams, you go to CPA section 5. That means we are moving from the current state times transition matrix, so that you can go to the future state. Yeah, that's what I'm trying to illustrate. You're moving from one state, that's the current state, times a transition matrix to the future state. And it has this general format. In matrix form, A, B, C, D. That's the general format. You are moving from one state to another state, from to two, through a transition matrix. So, what's that transition matrix? What's a transition matrix? It's also known as transition probabilities. So, transition probabilities. Now, transition probabilities is the probability of movement from one state to another. So, is the probability of movement from one state to another. Yeah, that's what we call a transition matrix or transition probability. So that's all about how you the concept of Markov analysis. You're just moving from one state to another. Now, when I talk about those states, what are the states do we have in Markov analysis? So let's look at the type of states. We look at types of states. What are the type of states we have? So we have 4 states. One is what we call open or recurrent or transient state. Then number 2, we have what we call absorbing state. Number 3, we have what we call, that's absorbing, and then we have, number 4, we have what we call equilibrium, or what we call a steady state or long run state, and then we have closed state. Those are the 4 major states we have. Those are the 4 states we have. So, number one is the open or the recurrent state. Now, an open state, this is where it's open. Members can join and they can exit freely. That's what we call open or recurrent state, where members can join and exit freely. Then we have absorbing state. Absorbing means that it's a state where members can join but they cannot exit. That's why it's called an absorbing state. Members can join, but they cannot exit. And then we have a closed state. And a closed state, this is where new members can, and a closed state, this is where no new members can join and no members can exit. So it's closed. So we are saying that, and a closed state, this is where no members can join and no members can exit. So that state is closed. And then lastly, we have what we call equilibrium or steady state. Now, equilibrium, you see at equilibrium, you see everything is equal, or steady, that means nothing is changing. And equilibrium is a state where the current and the future state, they are the same. That means the transition matrix has no effect. So you're saying that under equilibrium is where the current and the future state are equal. And that means that the transition matrix has no effect on the transition matrix. What do we mean? So for example, let's go back here. We are saying that under Markov analysis, you're moving from one state to another. So in this case, our current state, if you multiply by the transition matrix, you go to the future state. But now you find that this future state is the same as the current state. So we are saying that in this case, the current state will be equal to the future state. Or we can say that, let me give an illustration. A CPA section 4 student times transition matrix, you go to another state which is the same as the current state. Even next semester, it will be in CPA section 4. It's just an illustration, that a CPA section 4 student times transition matrix, even the next semester will be in CPA section 4. So that means you got a refer. So that's what we call a steady or an equilibrium state, where the current state and the future state are the same. So those are the states we have, and we have said that number one, we have the open state. And open state is where members can join and exit freely. Then we have absorbing state. Absorbing state is a state where members can join but cannot exit. And then number three, we have said that we have the closed state. And the closed state is where no new members can join and no members can exit. So that state is closed. And lastly, we have equilibrium or steady or long run state. And we have said that the long run state is where the current state and the future state are the same. That means that transition matrix has no effect on the current state. So that's it. So now I want us to look on something else. We can look at something else. So what are the characteristics of Markov analysis? So let's look at the sum of the characteristics of Markov analysis. And Markov analysis has 4 major characteristics. And characteristic number 1 is that the summation of raw element is equal to 1. We are saying that, for example, if you have A, B, C, and D, remember we are saying that we are moving from one state to another. One of the characteristics we are saying that the summation of raw element, this is our row. If you add A plus B, you should get 1. If you add C plus D, you should also get 1. So we are saying that the summation of raw elements should always equal to 1. So what does that mean? If you add A plus B, you get 1. That means A and B, they should be in empirical probability. So the other characteristic, we are saying that the elements or the raw elements are empirical probabilities. So that means they should be in terms of probability. Then another characteristic is that, characteristic number 3, is that rows shows retentions and losses too. And number 4 is that columns shows retentions and gains from. Yeah, those are the characteristics of Markov analysis. That summation of raw element is equals to 1. The element, therefore, the empirical probabilities. And then row shows retention and losses too. What does that mean? That means, assuming you have this matrix, we have company A and we have company B. A, B. We are saying that we are moving from one state to another. You are told that from our previous session or from our previous year, A retained 80% of its customer. So that means from A to A, they retained 80% of their customer. So what does that mean? If they retained 80, that means they lost 20%. So to B, you show 0.2. That's why I'm saying that the row will show the retention and losses too. And another characteristic is that if you add the two, you should get 1. And they should always be in empirical probabilities. Now, assuming that B, now we are moving from B, B, from a previous year to this year, they retained 70% of their client. B retained 70. So, from B to B, they retained 70. What does that mean? Here, how much did B lost to A? So, that means they lost 30%, 0.3. So, you show the retention and losses too under the rows. And the summation of the two should always give you 1. Then number 4, you have said that the columns shows retention and gains from. So now let's come to this. The column. We have said that column shows retention and gains from. Now A to A, it retained 80, but A gained 30 from B. So that's why you are told that. You see from the row wise, if B retained 70, that means he lost 30. If B lost 30, so that means the 30 went to A. So that we are saying that the column will show retentions and gains from. So from B that shows that B retained 70 but gained 20 from A. So the row will show the retention and losses, but the column will show the retention and gains from. So those are the sum of the characteristics of Markov analysis. So now I want to show you what are the sum of the assumptions. We look at the assumptions. Assumption of analysis. So what are those, or some of the assumption of Markov analysis? Is that number 1, the states are finite and constant. Finite and constant. And then number 2 is that there is no absorbing state. It assumes that in this case there will be no absorbing state. Remember I said that absorbing state, this where the members can join but they cannot exit. So in this case we assume there is no such state. And then assumption number 3 is that the probabilities. The probabilities are empirical and constant. And then number 4 is that the number of states are limited and unchanging. They don't change. They are unchanging. Another assumption, we can say that transition matrix can only be used. Transition matrix can only be used to forecast future state. You can only use transition matrix to forecast the future state, but you cannot use a transition matrix to forecast the previous state. So you can only be able to forecast the future state. So those are the some of the assumptions of Markov analysis. Now let's look also at what are the some of the applications. Application of Markov analysis in business. Where do you use Markov analysis in business? Remember you said that Markov is all about the study of movement from one state to another state. So one of the applications is that they are applied in education institution. Applied in education institutions to study transition of students. Transition of students. Then another application, they are used in human resource management to study labor turnover. Also, they are used in financial accounting. financial accounting to study bad and doubtful debts. Bad and doubtful debts. And number 4, they also used in financial markets. In financial markets. Yeah, to forecast prices. Forecast prices. Yeah, you can say prices of the shares, or you can say price of assets. Also, another application is that they are used in marketing and advertisement. Marketing and advertisement. Used in marketing and advertisement to study customer behavior. To study customer behaviors. Yeah, those are some of the applications of Markov analysis that they are used in education institutions to study transition of students. Now, for example, for those who are doing CPA, we have some students, I don't mean it's you, who have gone to all the CPA colleges in this town. They go to this college, they fail. They blame the teacher of this institution. They go to another institution, they fail again. After that, they'll go to another institution so that maybe they don't want the other lecturer to know that they failed. So we found that from section 1 to section 6, that guy or that student has gone to more than 6 or 7 colleges. We have some students who can give you a history of all the colleges in town or the colleges we have. So in that case, we can be able to study the transition. So for example, in this case, we can see that from our college, that's KCE college, we can be able to determine how many students move from this college, maybe from Summit Institute. How many students move from RCM? How many students move from maybe Star College to our college? And then we can also determine how many students did we lost this semester. From last semester, they never came back. So that we assume that they went to another college. So that's how we can use Markov analysis in education institution to study the transition of students. Then it's also applied in human resource management to study the labor turnover. And then financial accounting to study bad and doubtful debts. You see, in this case, you can use how much was the provision for the previous period for bad and doubtful debts, so that you can be able to forecast how much will be our provision for doubtful debts in the coming period. So you're using the current state to forecast for the future state. And then also used in financial markets to forecast the prices, and also marketing and advertisement to study customer behaviors. Yeah, those are some of the application of Markov analysis in business. So now with that, now we can go to illustrations. May 2015, we do May 2015, question 2B. May 2015, question 2B. So that I won't read that question. I'm hoping you are there. Make sure you have your past paper with you. So, and it's saying that Excellent Computer Limited deals in the production of printed ribbon. Out of the total number of customers who uses the uses the company printed ribbon in a given year, 20% uses competitors' ribbon the following year. Out of the total number of customers who uses competitors' ribbon in a given year, 30% switches to Excellent Computer Limited ribbon for the following year. As at that 1st December 2014, Excellent Computer Limited had a total market share of 55%. Required transition matrix. How do we get the transition matrix? So number one, you have to understand that question well. So to get the transition matrix, how many companies do we have? So in this case, we are told that we have Excellent Computer Limited, and then we have the competitor. So we have Excellent Computer Limited and the competitor. Excellent and competitor. We want to develop what we call a transition matrix. You are moving from one state to another. Excellent Computer Limited, and this is the competitor. So now let's get the transition matrix. So I read again. So we are told that Excellent Computer Limited is in the production of printed ribbon. Then out of the total number of customers who uses the company printed ribbon in a given year, 20 uses competitor's ribbon in the following year. So we are moving from our excellent computer, 20% uses the competitor the following year. We are moving from here to here. So 20% uses the competitor the following year. So that means excellent maintained or retained what proportion? If they lost 20%, that means they retained a proportion of 80%. I continue. Out of the total number of customers who uses competitors ribbon, so now we are moving from competitors, who uses competitors ribbon in a given year, that switches to excellent computer ribbon the following year. So of those who used competitor ribbon in a given year, 30% switches to excellent computer. So 30 switches. So that means competitor retained how much? Competitor retained 0.7. Now that's what we call the transition matrix. So that was number 1. Let's go to number 2. Number 2 of the question. Number 2, you are supposed to determine excellent computer limited market share as at that 1st December 2015. So they want to get the market share for 2015. So if you want to get the market share for 2015. So what you do, you take 2014, you multiply by the transition matrix for you to get the market share of 2015. And you are given for 2014. Let me read again. We are told that as at that 1st December 2014, Excellent Computer Limited had a total market share of 55. So as at the end of 2014, our Excellent Computer Limited had a market share of 55. That means competitor had a what market share? That means competitor had a market share of 0.45. So that's the market share as 2014. Then you multiply by transition matrix. Now transition matrix does not change. It's what we have developed here. So we have 0.8, 0.3, 0.2, 0.7. So now we can get that market share. So that means using the rule of, we say that you take first row, first column, first row, second column. So like in this case, you'll take 0.55 times 0.8 plus 0.45 times 0.3. So what do you get? 0.55 times 0.8 plus 0.45 times 0.3. So, and with that, you'll get it's 0.575. Now, to get for the competitor, first row, second column. Okay, it's not a must you have to compute. It's not a must you have to compute. Let me give you an easier shortcut. You see, you have said that if you add the two, you should get 1. So what does that mean? If you have for the first one, to get the second one, you just take 1 minus this. So if you take 1 minus that, and you have it's 0.425. Or you can still try. If you take 0.55 times 0.2 plus 0.45 times 0.7, you should still get that. But the easier way is you just take 1 minus that. So what does that mean? That means the Excellent Company Limited, as 2015, the market share will be 57.5% and the competitor will be controlling 42.5%. So that's what was required. You get the market share as 2015. Excellent Company Limited will be controlling 57 and the competitor will be controlling 42.5. And lastly, part 3 of the question. You are supposed to determine Excellent Computers Limited long run market share. Excellent Computer Limited long run market share. So they want the long run. Long run. And we said long run, it's also known as equilibrium. It's also known as the steady state. Steady state. And we said that under long run state, the current state will be equal to the future state. So that means the current state times the future times transition matrix to get the future state. So in this case, we have two companies. We have Excellent and we have the competitor. If you multiply by transition matrix, what do you get? So this is the current state. You multiply by the transition matrix, you go to the future state. But you see that the future state will be equal to the current state. So even the future state will be the same as this. E, C. Hope you're okay. the current and transition matrix, you get the future, which will be equal to this. And that's why we are saying that this implies that transition matrix has no effect to the current state. Then you do like this. So let's be here. You take the first element, which is E. If we have E, can we be able to get C? If we have E, can we be able to get C? Yes, remember you have said that if you take E plus C, if you add the two, you should get 1. So, can we get C if we have E? So to get C, it will be 1. This one you take it to the other side, minus E. That's how you get C. So in this case, you will do this. For the first element, you maintain it. But for the second one, you change it. If you have, now assuming E, it's 0.8. So that means C will be 0.2. So that's why you're doing that. You're just taking 1 minus this. So our C will be 1 minus E. Like that. Times transition matrix. Now transition matrix remained to be the what we had gotten here. And our transition matrix here, it was 0.8, 0.3, 0.2, 0.7. That one does not change. Is equals to, we are saying that the current state and the future state will be the same. So this one will still get E 1 minus E. Yeah, the current and the future state, they are the same. So from there, so how do we get that? First row, first column, you get E. First row, second column, you get 1 minus E. So I repeat again. If you take first row, first column, you should get E. First row, second column, you get 1 minus E. So let's do that. We do with the first. So it will be E times 0.8, you will get 0.8 E plus 1 minus E times 0.3. So what do we do that? It's 0.3 times 1, you will get 0.3 minus 0.3 times E, 0.3 E is equals to, we have said that first row, first column, you get E. So this one should equal to E. Then you bring the right term together. So you have 0.8 E minus 0.3 E, still we have another E. If you take E to the other side, it becomes a negative. So you take 0.8, so you're taking 0.8 minus 0.3 E, 0.3, minus, this is 1 E. If you take it to the other side, it will be minus 1, minus 1. And you'll have negative 0.5 E is equals to, here we have positive 0.3. You take it to the other side. So it will be a negative. It will be negative 0.3. So can we get E? Yes. To get E, you divide both sides by negative 0.5. Divide by negative 0.5. That means our E, so if you take 3 divided by 5, that I think is 60. Yeah, it will be 0.6. So that means our competitor, our C. We have said that. How do we get C? It's 1 minus E. So that means 1 minus 0.6, you will get 0.4. So we are saying that if the current state or the transition matrix does not have effect on the current state, in our long run, assuming everything remains constant, in the future, Exxon should be controlling 60% and the competitor will be controlling 40%. So this is the same as 60% and this one is 40%. So that's how we get the long run. So don't worry if you have not gotten that. So I'll still be doing more illustration. I want you to get this because this area of Markov analysis is usually highly examinable. It's highly examinable. And the matrices, these are the most highly examinable part. So you can look at that for 10 seconds for what we have done. Then we do another illustration. So let's do another illustration. I want us to do September 2015, question 1A and B. September 2015, question 1A and B. Hoping we are there. Let me read the question. Part A. I start with part A. Highlight 4 assumption of Markov analysis. The assumption of Markov analysis. I've already highlighted the assumptions. I'd already given you the characteristics. So in this case, they want the assumption of Markov analysis. And you get your 4 marks. Now, let me go to part B of the question. Part B, you are told that the research industry in your country has 3 market research firms, namely X, Y, and Z, which provides research services. I know I told that. The following data has been corrected in relation to the flow of clients among the 3 firms. So we have, you are given company X, Y, and Z. Then you are given the number of clients. So this is what you have. You have as company X, Y, and Z. Then we have the number of clients. That's at 2013. X had 408, 832, and 1062. So if you want to get the market share, how can you convert this data into probability? So for 2013, you just add the total, 408, 832 plus 1062, you get the totals. After you get the totals, for example, to get the proportion for X, you just take 408, you divide by the total to get the proportion. So you are given the number of clients and the market share. Then you are given flow of clients. And for the flow of clients, you are given gains from and losses too. Gains from and losses too. Required, number 1. Convert the data above into matrix of transition probability. So you determine that. In short, you are determining the transition matrix. So now, when you are determining the transition matrix, in this case, you are given gains from and losses too. So kindly focus on the losses too. You focus, if you're given the gains from and the losses too, so kindly in this case, you focus on the losses too. Because we say that the row will show the retention and losses too. And then if you add the summation of the row element should give you 1. So that's why I'm saying in this case, I'm ignoring the gains from, I'm taking the losses too. And this is what you are given for the losses too. That's the information given there. You are given for X is dash, Y is 30, Z is 18. And you are given like that. Those are the flow of clients during the year, and you are given the losses too. Then the question is, you convert the above data in transition probabilities. How do we get the transition probability of the transition matrix? So this is what you do. You have X, you have Y, and you have Z. I have like that. X had 408 members. This one had 832, and this had 1062. That's X, Y, and Z. And then you are given here that X, we are moving from one state to another. From X lost 30 to Y, and X lost 18 to Z. And then you are given dash. Remember we said that row shows retention and losses too. The retention and the losses too. So for example, in this case, this is what you will do. X, we had 408 members. We lost that to Y. We lost 18 to Z. So how much did we retain? So that's what you do. You do 408 minus 30 minus 18. And you'll have 360. We go to Y. Y here you are told that Y lost 24 to X and lost 14 to Z. That's the losses too. So can we be able to get the retention? Because this one given as dash. So you take 832, you raise 24, you raise 14, and you have an amount of 794. Z, we had 1062 members. Then here you are given the losses too. We lost 40 to X, we lost 10 to Y. So can we be able to determine how much did we retain? So you take 1062 minus 40 minus 10, and you have 1012. So now let's convert that data into empirical probability. Remember I said that there should be empirical probabilities. In that, if you add all of them, you should get 1. So how do we do that? So how do we convert this data into probabilities? So for X, you just divide by the total. The total was 408. So you divide by 408, 408, 408. For Y, the total number of members was 832, 832, 832. And then for Z, we had 1062, 1062, 1062. So you get that. So 360 divided by 408, that one you get 0.88. That you divide by 408, you'll get 0.07. Then the last one, remember I said that the assumption is that if you add the 3, you should always get 1. So you have the first one and the second one. The third one, because here we have made a rounding off, you can just take 1 minus 0.88 minus 0.07 for you to get for Z. And in this case, you'll get 0.05. You go to Y, 24 divided by 8, that's 2. You'll get is 0.03. 794 divided by 8, that's 2. You'll get 0.95. Now, for the last one, you don't have to compute because here we have made a rounding off. So, for you to get an exact one, you just take 1 minus 0.03 minus 0.95, and this one you will get it's 0.02. And lastly, 40 divided by 1062, you'll find that one is 0.04. 10 divided by 1062, you'll get it's 0.01. And lastly, the last one you just take 1 minus 0.04, 1 minus 0.01, and you get 0.95. Yeah. That's how you get transition matrix. And that was the requirement for number 1. Now let me go to number 2 of the question. Number 2. You estimate each firm market share for 2015. You estimate for each firm market share for 2015. Market share for 2015. Now, how can you get the market share for 2015? To get for 2015, you'll take 2014 times transition matrix, you get for 2015. You get for 2015. And from the question, you're already given that. After the flow of clients, you had the number of clients as at that 1st December 2014, and then you have the market share. So you're already given the market share for 2015. Sorry, for 2014. For 2014, X had a market share of 0.184, Y had 0.362, and Z had 0.454. So I've just taken the market share for 2014. I multiply the transition matrix. Now, transition matrix is what you have developed here, and that one does not change. What you have developed here at step number 1, that's the transition matrix, where we had 0.88, 0.07, and 0.05, 0.03, 0.95, 0.02, 0.04, 0.01, 0.95. So let's get that. So first row, first column rule. You do first row, first column, you get the market share. So that means for X you'll get it 0.19. For Y, it will be first row, you multiply by the second column. That one you get an amount of 0.36. To get for Z, you have for X and you have for Y. How do we get for Z? It's 1 minus 0.19, 0.036. And in that case, you have it's 0.45. So that means the market share. So this is for X, Y, and Z. The market share for X, for Y, and Z. For X is 0.19. So that one in short is 19%. We'll be controlling 19% of the market. Y is 0.36. That means they'll be controlling that 6% of the market share. And lastly, Z will be controlling 45 of the market share. 45 of the market share. So you can look at that. So let's try another illustration. We do another illustration still on Markov analysis. November 2018, question 2B. November 2018, question 2B. So let me read the question. And we are told that X limited, Y limited, and Z limited, this in the production of detergents. On 1st January 2017, the 3 companies introduced a similar new detergent in the market. Prior to introduction of the new detergent, the 3 companies had an equal share of the market. They had equal market share. If there are 3 companies, equal market share, that means they had a third, because there are 3 companies. A survey conducted on the market share of the 3 companies as at that 1st December 2017 revealed the following. So we are given all that details. Required, number 1. The market share of the 3 companies as that 1st December 2018. And number 2, the long run market share of the three companies. So starting with the number to get the market share. So number one, you are not given the transition matrix. So first of all, you have to get the transition matrix. And how do we get the transition matrix? In this case, we have three companies. We have X, Y, and Z. X, Y, Z. You are moving from one state to another. So first of all, let's develop the transition matrix. And I start with additional information, the number one. Additional information number one. We are told that a survey conducted on the market share of the three companies at the 31st December 2017 revealed the following. So, number one, X Limited had retained 90% of its customer. X had retained 90% of its customer, but had lost 3% and 7% of its customer to Y and Z. It had lost 3%, so you had 0.03 and 7%, 0.7% to Y and Z respectively. Remember I said that the row will show the retentions and the losses too. Number two, Y Limited, so now we are moving from Y. Y Limited had retained 75%, so YY had retained 75% of its customer, but had lost 10% and 15% of its customer to X and Y, to X and Z Limited respectively. So had lost 10% to X and 15% to Z. And then number three, Z Limited, so now we are moving from Z. Z Limited had retained 80%, so Z had retained 80% of its customer, but had lost 5% and 15% of its customer to X Limited and Y Limited respectively. So had lost 5% and 15% respectively. So now that's how you develop the transition matrix. Now, required number one. Number one, you're supposed to get the market share of the three companies as at that 1st December 2018. So we get that. So you want market share as at that 1st December 2018. So how do we get for 2018? For you to get for 2018, it will take 2017 times transition matrix to get 2018. But what's the information given here? Let me take you back to the question. You are told that X Limited, Y Limited, and Z Limited, this in the production of detergent. On 1st January 2017, the three companies had equal market share. So that's as at 1st January 2017. So that means if you want to get at the end of 2017, so now we want to, first of all, you see this one we want as at that 1st December 2018. So first of all, you have to get market share as at that 1st December 2017. You have to get that. And how do we get that? So we are given as at January. You are given as at January. And how much was as January? We told that they had. So the market shares at that 1st December 2017. It will take the market share as January. We are told that on 1st January 2017, they had equal market share. So that means equal, that means is 0.33, 0.33. Then the last one, you see if you add the three of them, it should give you 1. So you can give it 0.34 times the transition matrix, and we are given the transition matrix, what we have computed there, 0.9, 0.1, and 0.05, 0.03, 0.75, and 0.15, 0.07, 0.15, and 0.8. Now you can get, so in this case we are looking at that 1st December 2017. So I have taken the market share as the first as January 2017. You multiply by transition matrix for you to get as December 2017. So what do you get? First row, first column. So that one we get 0.35, 0.31, and 0.34. That's what you get. Then you use that one as at December 2017. So now you get, to get as at that 1st December now 2018. To get at that 1st December 2018, you will use December 2017 times transition matrix for you to get for 2018. That's why first of all you have computed for at that first December 2017, and which we have there, it's 0.35, 0.31, and 0.34. You multiply by the transition matrix, and the transition matrix is what you have developed here, which is 0.9, 0.1, 0.05. That one does not change. 0.75, 0.15, 0.07, 15, and 0.8. Now we can be able to get as at that first December 2018. First row, first column, first row, second, and third. You know how to multiply that. So in this case, we'll have 0.363, 0.294, and lastly we have 0.343. Yeah, that's the market share as at that first December 2018. That's what we'll be controlling. Good, and you have your 3 marks. So, part 2 of the question, part 2 you are told that the long run market share of the 3 companies, the long run, and that one has 9 marks. So, what did we say about the long run? Long run is also known as the steady or equilibrium, and we say that under this, the current state and the future state will be the same. So, let's get that. In this case, we have 3 companies, X, Y, and Z. So, number 2, we are doing long run. So, this is what you'll do. The current state, we have X, Y, and Z. You multiply by the transition matrix, you should still get X, Y, and Z. Yeah, the current and the future state will be the same. Then, you say that you maintain the first one and the second one. If you get X and you get Y, can you be able to get Z? Yes, if you take X plus Y plus Z, it should give you 1. So if you have X and you have Y, to get this Z, you just take 1 minus X minus Y. So that means to get Z, it should be 1 minus X minus Y. You multiply by the transition matrix. This is our transition matrix. That one does not change. You have it 0.9, 0.1, 0.05, 0.03, 0.075, 0.15, 0.07, 0.15, 0.8 is equals to, we have said that the current and the future state will be the same. So even our future state will be X, Y, and our Z we have seen is 1 minus X minus Y. Like that. So now let's start solving. First row, first column, you should get X. First row, second column, you should get Y. First row, third column, you should get 1 minus X minus Y. So let's start with the first one. First row, first column to get X. So in this case, it will be X times 0.9, you will have 0.9X plus Y times 0.1, you have 0.1Y plus 1 minus X minus Y, you multiply by 0.05, you'll get 0.05 times 1, you have it 0.05 minus X times 0.05, you get 0.05X minus Y times that, you get 0.05Y is equals to, we have said that first row, first column, you get X is equals to X. Then let's bring the right term together. 0.9X minus 0.05X, we have another X here. If you take this X to the other side, it becomes a negative. So it's 0.9X minus 0.05X minus 1X. And you'll find that your X will be negative 0.15X. What about Y? Y, we have 0.1Y minus 0.05Y. And you have a positive 0.05Y is equals to, this is 0.05, you take it to the other side, it will be a negative. So it will be a negative, you have negative 0.05. And you can call it equation number 1. Call it equation number 1. Because we have X and we have Y. So now let's try to use the second column there. First row, second column, so that you can get your y. So it will be x times 0.03, and you have 0.03x plus y times 0.75, you have 0.75y plus 1 minus x minus y, you multiply by 0.15. So in that case, you have plus 0.15 minus x times 0.15, you get 0.15x minus 0.15y is equals to y. First row, second column, you'll get y. Now let's bring the right hand together. We start with x. 0.03x minus 0.15x. What do you get? That one will have negative 0.12. 12x. And then we have y. 0.7y minus 0.15y minus y. If you take this one to the other side, it becomes a negative. So what you get there? You have minus 0.4 y is equals to, now this 0.15, if you take it to the other side, it will be a negative. So it will be equals to negative 0.15. You can correct equation number 2. Now with that, you can use equation 1 and 2. Using equation 1 and 2. Let's use equation 1 and 2. So equation 1 here, we had negative 0.15x plus 0.05y is equals to negative 0.05. Equation 2 here, we have it's negative 0.12x minus 0.4y is equals to negative 0.15. We have that. So we can use elimination and we can eliminate y. If you eliminate y, that means, or you can eliminate x. So this one you can multiply by 12. It's not necessarily you have to multiply by 0.12. You can multiply by 12. This one is 0.15, but you can multiply by 15. By 15. So what do we have there? So like the first one, you take negative 0.15, you multiply by 12. So what do we have there? We'll have 1.8x negative plus 0.05 times 12. You'll have 0.6y is equals to negative 0.6. This one you are taking 0.05 times 12, which is a negative. You have that. The second one, you take 15 times negative 0.12. You still get negative 1.8x minus 0.4 times 15. That one will get 6y minus 6y is equals to negative 0.15 times 15. What do you get there? So there we have negative 2.25. And then we want to eliminate x. So should we minus or should we add? So in this case, you minus. So that if you take negative 1.8 minus becomes a positive. And it will be eliminated. So what do we have there? So in that case, you have 6.6y is equals to 1.65. And that gives you a y. So how much will be y? So 6.6y is equals to 1.65. So to get y, you divide both sides by 6.6, 6.6. And you'll get your y at 0.25. If you get your y, you can get x and you can get z. How can you get x? So now let's go to any of the equation. For example, equation number 1. We have equation number 1. Let's use this. We substitute that. Because we already have y is 0.25. So if you substitute this equation, substituting y with 0.25, now you can be able to get x. I know you know how to substitute. I've taught that one in our previous sessions. So our x, you have it's 0.42. It's 0.42. So now we are remaining with the z. Can we be able to get z? Remember I said that if you have x and we have y, z is 1 minus x minus y. So you just take 1 minus 0.42 minus 0.25 and you get it's 0.33. So that means in long run, y will be controlling 25% X will be controlling 42% and Z will be controlling 33% in long run. Assuming nothing changes, that will be the proportion. That will be proportion. So you can look at that one for 5 seconds, what we have done. And kindly make sure you are practicing this, Markov analysis. Practice Markov analysis. And from the notes, I have indicated a lot of assignments. You can go and try those assignments from the handout. So let's go to the Rust application of matrices, and that's the Leontief's, or what we call the output-input analysis. And the Leontief analysis is a technique used to study the interdependence existing between various sectors of an economy. So we are talking about the interdependence means that the output of one sector will become an input of another sector. So that's what we'll be covering under Leontief, or that's what encompasses the Leontief analysis. It's also known as output-input analysis, where an output of one sector becomes an input of the other sector. So what are some of the terminologies used here? So one, we have what we call the intermediate demand. What's an intermediate demand? Now, intermediate demand is the demand or the output of one sector which will be used as an input in another sector. That's what we call intermediate demand. Output of one sector which should be used or which will be used as an input of the other sector. Then we have final demand. Now, final demand, this is the output which will be used by the final customer. Is the output of the final customer. That's what we call the final demand. And then we have the total demand. Total demand is noted by X. Now, total demand is comprises of the intermediate demand and the final demand. And I've written that at that total demand is equals to intermediate demand and the final demand. So, and this is how we get the Leontief equation. X, now X is the total demand, is equals to, this is not I, this is what we call identity matrix. This identity matrix minus A, our A in this case will be representing what we call technological coefficient matrix, and then you get the inverse, and then you multiply by D. We have said that D is our final demand. So this equation is very important. We are saying that this X is the total demand is equals to I minus A, you get inverse, and then you multiply by the final demand, where X is the total demand, A is the technological coefficient matrix, D is our final demand. This identity matrix minus A, is known as the Leontief matrix. And then with this inverse, it's called Leontief inverse matrix. And this I is what we call identity matrix. We have defined what's an identity matrix in our previous session. Yeah. So with that, now we can do an illustration. With that, let's do an illustration. And I won't write a given illustration here. Allow me to write illustration. So let me just write it. So that a two-sector economy has the following input, output. So we are given A, we have P, we have Q, P, Q, like that. Like that. Then you're given that the final demand Good. So that's the question. And you are told that a two-sector economy has the following input-output. So you are given that, and this is A. Remember we said A is what we call technological coefficient matrix. So we have that. Then we are told that the final demand for the next year is estimated as P, we estimate a final demand of 50, and Q estimate a final demand of 80 required. Determine the total production. How do we get the total production? Solution. Let's do that solution. So in this case, we want to determine the total production. How do we get the total production? We say that total production is denoted by X is equals to, that was the formula. So we start with this. How do we get this? We say that X is the total output, identity matrix, technological coefficient matrix, and then this is the final demand. So this is what you do. First of all, we get this, the Leontief matrix. We take I, this is the identity matrix, and then we say that identity matrix, in this case, what you are given here as a technological coefficient is a 2 by 2 matrix. So that means identity will be 1, 0, 0, 1, minus A is the technological coefficient of which we are given here. We are given 0.3, 0.5, 0.2, and 0.4. What do you get? What do you get? We are taking I minus, so this is that. So you'll take 1 minus 0.3 and you have 0.7. 0 minus 0.2, you get negative 0.2. 0 minus 0.5, you get negative 0.5. And 1 minus 0.4, you get 0.6. That's what you get. And then this I minus A, and then you get the inverse. So what you have gotten here, we get the inverse. How do we get an inverse? So you said step number 1, you have to determine the determinant. How do we get the determinant? So in this case, you'll take 0.7 times 0.6 minus negative 0.2 times 0.5. That's how you get the determinant. And in that case, you'll get a determinant of how much? So you'll get a determinant of 0.32. So if you take 0.7 times 0.6 minus negative 0.5 times negative 0.2, you get a determinant of 0.32. Then you get the reciprocal. So it will be 1 divided by 0.32. After you get the determinant, you reciprocate. And then we say that for the major diagonal element, you interchange. So like this one, you have 0.6 goes up and 0.7 goes down. But for the minor diagonals, we say that you just change the sign. So this one will be positive 0.2 and this will be positive 0.5. So by that now you have I minus A and the inverse. And then you can multiply by D. You can multiply by D. And we say that D is what we call the final demand. So we already have all this. We have this. And then you multiply by D and you are given the final demand. So you are told that the final demand for the next year is estimated at P, it's 50, and Q was 80. Q was 80. So what do you get? So in that case, you take 0.6 times 50 plus 0.2 times 80. Then what you get, you multiply by 1 divided by 0.32. And in that case, you will have 143.75. They were in million, sorry. This was 50 million, this was 80 million. And then, to get for Q, you will take 0.5 times times 50 plus 0.7 times 80. And in that case, you should get 253. So that's how you get the final demand. That's how you compute a final demand. As simple as that. So that's all about Markov analysis. And from the handout, I've done another illustrations. I've done other illustrations, so you can try and follow what you have written there under the notes. So, and that's the end of today's session. So make sure before you have the previous session, because it was also Markov analysis. That's when we discussed the basis of matrices. So thank you.